Good morning, students. Welcome back to chemistry class. I believe you all are studying the lessons whatever I taught you. Now we are in lesson 3. We already discussed acid and its preparation method. In this session, we are going to discuss salts and its preparation method. We already know how this salt was formed. Basically, the salt was formed by the neutralization reaction. Here, the definition of salt is a compound formed by the partial or total replacement of the ionizable hydrogen atoms of an acid by a metallic ion or else ammonium ion. Here, the partial displacement, the first reaction, sodium nitrate is reacting with sulfuric acid. The temperature is below 200 degrees Celsius. The salt, sodium bisulfate was formed. Then the nitric acid, along with that we are getting. The next thing, complete replacement. Why it is complete replacement? When the acid is reacting, whatever the hydrogen is present in that was completely replaced. Then only the reaction was complete. That's why for the before reaction, we are replaced only one hydrogen atom, so that we need to remove two hydrogen atoms. So the next reaction, two molecules of sodium nitrate is reacting sulfuric acid, and then it is giving sodium sulfate, and then two molecules of nitric acid. Ionic definition. Why we need ion? When the salt is dissolving in the water, it is giving H plus proton or else OH minus ion. Here we have an example. Sodium chloride is reacting. It gives sodium plus and then chlorine minus ion. It is happening when it is dissociate in water. Based on this, we have a classification of salt. We have a 6 classifications. They are normal salts, acid salts, basic salts, double salts, mixed salts, and complex salts. We are going to discuss these type of salts briefly in this lesson. Normal salt. What is a normal salt? Normal salts are the salts formed by the complete replacement of the ionizable hydrogen atoms of an acid by a metallic or an ammonium ion. Here the example is hydrochloric acid yields sodium chloride when sulfuric acid gives sodium sulfate. Yes, when the base is reacting corresponding acids, it is liberating the different types of salt. When hydrochloric acid reacts, it gives sodium chloride. When it is sulfuric acid, it is giving a salt sodium sulfate. Normal salts have no ionizable hydrogen atoms, yes, because the hydrogen was replaced to water. Here it is a simple neutralization reaction. Our second type salt is acid salts. Acid salts are formed by the partial replacement of the ionizable hydrogen atoms of a polybasic acid by a metal or an ammonium ion. Here, example is dibasic sulfuric acid. It is sodium hydrogen sulfate. Why it is dibasic? Here, this sulfuric acid has a two hydrogen atom in it. So, obviously it is dibasic. We already discussed in the type of acids. This sulfuric acid, when it is reacting sodium chloride, the temperature is above 200 degrees Celsius. It becomes sodium bisulfate and corresponding hydrogen chloride is evolved. Acid salts are usually formed when the amount of base taken is insufficient for the complete neutralization. Why the amount of base is insufficient for the reactant? So that we are getting acid salt. The acid salts ionize in water to give hydronium ion. It shows all the properties of acid because the partial ionization of base only present here. So obviously it is acid. So it shows the characteristics of acid. Basic salts. Basic salts are found by the partial replacement of hydroxyl group or a di or a triacidic base by an acid radical. Here, the replacement of hydroxyl group, it forms a salt. Example for this, basic lead chloride. Why it is basic? So, the OH group is present in the salt itself. PbOHCl, and then basic copper chloride, CuOHNO3. Here, the first reaction is the lead hydroxide is reacting hydrochloric acid and then it is giving out a basic lead chloride and then water is removed. This is also type of neutralization reaction, but here the hydroxyl group is present in the salt itself, so that we can say it as a basic salt. Our next type is double salts. Double salts are formed by the union of two simple salts that dissolve in water and crystallize. Yes, here see the potash alum. The formula is K2SO4, Al2SO4 thrice and 24H2O. Yes, two different salts are present in a one salt. That's why we are saying it's a double salt. When this one dissolve in water, we can get the crystals of this salt. Another example is Mohs salts and then dolomite. Here we have a mixed salts. Mixed salts are those salts that contains more than one basic or acid radical. Here the example is sodium potassium carbonate NaKCO3, then bleaching powder CaOCl2. See here two in the sodium potassium carbonate, two metals are present in the carbonate salt. As well as the bleaching powder, it has a calcium oxide as well as chlorine group. That's why we are saying this is a mixed salt. Our next salt is complex salt. This is the last salt. Complex salts are those which on dissociation give one simple ion and one complex ion. So it's very complex. So two or more elements are present in that. Here we are taking sodium argentinosinate. It's a reversible reaction. When it is dissociated in water, it is giving Na plus ion and then argentinosinate anion it is giving. So sodium argentinosinate when it is dissolved, it is giving a one simple ion Na plus and then silver argentinosinate, it is a complex ion. That's why we are saying this is a complex salt. Here the preparation of salts. The first method is preparation of insoluble salts. For this preparation, we have two types. First one is double decomposition. In this, it is done by mixing two compounds, one containing the metallic radical and the other the acidic radical of the required insoluble salt. So what they are saying, one contains metallic radical. Here, copper oxide contains a metal copper, so it's a metallic radical as well as acid radical. The sulfuric acid is reacting, sulfuric acid is acid radical. So here the displacement is taking place. The copper becomes a copper sulfate and then the remaining two hydrogen atoms present in the sulfuric acid, it comes out as a water. Next, combination of constituent elements. This involves the combination of the elements that make up the insoluble salt. Why it a constituent element? Here, no acid and base are taking part in this reaction, only the element taking part and it is giving a corresponding salt. So, Fe is reacting sulfur, it is a ferrous sulfur and then Fe is reacting chlorine, it is giving ferric chloride. Our next method is neutralization of an acid and insoluble base. So we are neutralizing this acid. Copper 2 oxide is an insoluble base. If we add it to warm dilute sulfuric acid, the solution will gradually turn blue. Here, the copper oxide. In a solution, it is black in color. When it is reacting sulfuric acid, it becomes a copper sulfate. So when it has a copper sulfate, it turns into blue color and water has comes out. The reactions are first copper oxide is taking a two hydrogen atoms and then It has been reduced to copper 2 ion and then water comes out. The next step is the O2 minus is present in the copper. It is reacting to hydrogen atoms and it becomes a H2O. So this is the reactions involved in this neutralization of acid and insoluble base. Double decomposition reaction. An insoluble salt can also be obtained from another insoluble salt by double decomposition reaction. Here barium chloride is reacting sulfuric acid and it is giving barium sulfate. It has been precipitated in the solution and then corresponding we are getting hydrochloric acid. Next, the laboratory preparation of salts. The first one we are going to prepare anhydrous ferric chloride. In this, we are in this test tube first we are taking concentrated hydrochloric acid and then manganese dioxide. Through this, here the chlorine gases comes out. In this chlorine gas contacting the next tank, it is filled with concentrated sulfuric acid. This concentrated sulfuric acid is acting as a drying agent. Why we need a concentrated sulfuric acid? When the reaction takes place, some of the impurities present as well as the moisture is present in the gas. With the help of sulfuric acid, we are removing the moisture from the chlorine gas. After that, the chlorine gas becomes a dried one. When the dry chlorine is going to contact the next test tube, it was filled with iron. In that iron, we are already giving a temperature to that. So when the chlorine gas goes and contact with the iron, it becomes a ferric chloride, iron 3 chloride. Then this iron 3 chloride goes in contact with the next conical flask section. Here we have a freezing mixture. Why freezing mixture? Because here we are giving the temperature to cool down these ferric chloride. We are having a freezing mixture. Then again this ferric chloride mixture is contacting to the next tube. It was filled with fused calcium chloride. This is also drying agent. Why we are needing a drying agent? When this ferric chloride, when it gets a moisture, it is deliquescent in reaction. Deliquescent, you already know, it is easily absorb water from the atmosphere. That's why we need to add fused calcium chloride to maintain a ferric chloride as a dry one. Anhydrous iron 3 chloride is prepared by direct combination. Why direct combination? When the chlorine is directly contact to the iron, it is reacting to give a iron 3 chloride. Iron metal is heated with dry chlorine gas. Here the reactions are, when the iron is reacting 3 chlorine, the dry chlorine, it gives out a ferric chloride. Iron 3 chloride is highly deliquescent, so it is kept dry with the help of fused calcium chloride. So here to keep a iron 3 chloride, we are using the drying agent of fused calcium chloride. For the chlorine gas, we used sulfuric acid as a drying agent. For the anhydrous ferric chloride cannot be prepared by simply heating the hydrated ferric chloride. When the hydrated ferric chloride on heating, it gives out ferric oxide, water and HCl. So we cannot get a ferric chloride from the anhydrous ferric chloride of 6H2O. Here the reaction FeCl3 6H2O, it gives out iron oxide, 9 water molecule and then 6 chlorine, hydrogen chloride. Anhydrous iron 3 chloride is used as a catalyst in certain reactions. For the laboratory reactions, we are using this catalyst. It is as a catalyst. We already know what is a catalyst. To speed up the reaction, we are adding the catalyst for the reactions. Here, the preparation of zinc sulfate. Zinc sulfate is otherwise known as white vitriol. The preparation is known as crystallization method. The steps we are going to discuss. The first step, we need to add zinc granulates to the dilute sulfuric acid. We have to give the temperature gently to dissolve the zinc granulates from the sulfuric acid. The second step is over. The third step, the reaction is complete. We get a solution of sulfuric acid mixed with zinc granulates. The next step, we need to filter this solution through that funnel. We have a filter paper and then we can pour the conical flask. We are getting zinc 2 sulfate solution. In this zinc 2 sulfate solution, again we need to transfer in a bowl to heat gently. Then what's happening? The solution is evaporating and then we get a saturated solution. When we keep the saturated solution at a rest, it becomes the crystals of zinc sulfate. So through the filter paper also we are getting zinc sulfate crystals when we are filtered that zinc sulfate solution. So either we can get a crystallization or else the powder is present in the filter paper. Next, the reaction is zinc oxide is reacting sulfuric acid and then water. It becomes a zinc sulfate heptahydrate. Then zinc is reacting sulfuric acid. It becomes a zinc sulfate and then hydrogen gases comes out. Here now we are crystallizing only zinc sulfate, zinc 2 sulfate salt. Preparation of iron 3 sulfate, green vitriol. It is prepared by the displacement reaction. When the iron is reacting sulfuric acid, it gives ferrous sulfate and then hydrogen gases comes out. The next step, when this iron sulfate is reacting 7 molecules of water, it is forming green vitriol, FeSO4 7H2O. Next, we are going to prepare lead chloride. The chloride of lead, silver and mercury and sulfates of barium, lead and calcium are also prepared in this reaction. Here the lead nitrate is reacting hydrochloric acid, that is giving lead chloride and then corresponding nitric acid comes out as a product. Calcium carbonate preparation. Here it is prepared by adding sodium carbonate solution to a hot solution of calcium chloride in a beaker. Here we need to add the excess sodium carbonate. Calcium chloride, when it is reacting sodium carbonate, it is giving calcium carbonate as precipitate and then we are getting a sodium chloride salt. The white precipitate of calcium carbonate is formed. Filter the calcium carbonate and wash it repeatedly. Why we need to wash it? Because we need to remove the impurities present in the calcium carbonate. The collected powder dry to obtain amorphous powder. Amorphous means either it may be a solid or else it may be a powder. In the same manner, carbonate of all metals can be prepared. But we have exceptions, sodium and potassium, then ammonium carbonates we cannot prepare in this method. Preparation of an acid salt, sodium bicarbonate, NaHCO3. The principle is by passing carbon dioxide gas into a cold solution of sodium carbonate. When the solution is cold, we need to pass a carbon dioxide gas into it. The reactions are sodium carbonate is reacting carbon dioxide gas and then water. We get the product of sodium bicarbonate. It is a acid salt. The procedures: dissolve nearly 5 grams of anhydrous sodium carbonate, about 25 centimeter cube of distilled water in a flask. Cool the solution by keeping the flask in a freezing mixture. Next, pass carbon dioxide gas in the solution. Crystals of sodium bicarbonate will precipitate out after some time. Filter the crystals and dry it in the folds of filter paper. See the procedure here. In this picture, the sodium carbonate as well as it is mixed with the distilled water as kept in the frozen beaker. When we pass through the carbon dioxide, the reaction is taking place. So it is giving out a sodium bicarbonate salt. Here the neutralization reaction, it is a different type, heat of neutralization. It is the amount of heat liberated when 1 gram equivalent of an acid or a base is completely neutralized. When it is happening, either it may be acid or base reacting together, That reaction we are saying as a neutralization reaction. In that reaction, the heat is liberated. We can say it as a heat of neutralization. Next, preparation of blue vitriol. Blue vitriol's formula CuSO4 5H2O. Otherwise, we can say it as a copper sulfate pentahydrate. By the action of dilute sulfuric acid on copper hydroxide. So here copper carbonate is reacting sulfuric acid. First it is producing copper sulfate, water, and then carbon dioxide gas is evolved. When the carbon dioxide evolved, copper sulfates again reacting with 5 molecules of water, and then it becomes a copper sulfate pentahydrate. The method used to prepare is crystallization method. So we already prepared zinc sulfate in the same method. So the same steps only we are going to follow to prepare a copper sulfate pentahydrate. Preparation of sodium sulfate. It can be prepared by reacting sodium salts, any sodium salt, with the sulfuric acid. It is forming a sodium sulfate. Here we are taken sodium carbonate, so it is giving corresponding sodium sulfate, water, and carbon dioxide. So other salts of sodium also we can prepare in this method. We can use such as sodium chloride. Because of its low solubility, sodium sulfate will be precipitated. So whatever the reaction, it is very less soluble in water, so we can get a precipitate of sodium sulfate. The resulting solid is filtered and dried to obtain the useful anhydrous form. Anhydrous means without water, we are getting a dry salt. Next, volumetric titration of sodium hydroxide versus sulfuric acid. Here it is acid-base neutralization reaction. We are taking a strong acid, sulfuric acid, and a strong base, sodium hydroxide. The products will be salt and water. Obviously, it's a neutralization reaction. Sodium hydroxide plus sulfuric acid. The product is sodium bisulfate and water. The reaction is highly exothermic as enormous amount of heat is liberated. It's exothermic reaction. We are using phenolphthalein as an indicator. The titration reaction, the purate we are taking a acid, and then in this conical flask we are taking the base sodium hydroxide as well as the indicator phenolphthalein we are taking. When the reaction taking place, we need to open a burette. Slowly the acid is contacting to the base present in the beaker. When a certain point comes, the solution turns into pink color. So the reaction is over. The solution is converted into sodium sulfate. On evaporating this solution, we can get crystals of sodium sulfate exohydrate. For the above titration, instead of taking sodium hydroxide, we can take sodium carbonate. So corresponding base, we need to take sodium carbonate. So instead of taking sodium carbonate, we can add methyl orange is an indicator for this titration. Here I am included some of the in-text questions. So gone through these questions carefully. Better you can take a notes for this one. For this current situation, ICSE board has decided to reduce your syllabus. For this current lesson, acid, base and salt, we have 3 subdivisions. First one is acid, base and its properties. Second subdivision is salt and its preparation method. Then third is properties of salt. So ICSE board has omitted the third part, the properties of salt. So you have only 2 subdivisions in this lesson. So the lesson is over. You can study your lessons carefully and then prepare well. Thank you, students. Have a nice day.